Hey, grade 8, welcome to your lesson on force, pressure, and area. This is all about hydraulics and pneumatics and studying how these systems can give us a mechanical advantage. So let's talk first of all about what pressure is. And this is something that I end up talking about in Chemistry 20 in grade 11. It's a pretty complex topic, but the idea of pressure is it's the force acting over a certain area. So if I take a look at some kind of an area or a shape, okay, it's the force that is acting on that area. So that's pushing on that area. Now, if I increase the area, well, then my pressure goes down. And if I increase the force, my pressure goes up. So the idea is that it's force per area that the force is acting on. And actually, think about it this way. Let's say, oh, this is going to be a horrible sounding example. Let's say that you press into your hand, okay, with your finger. We're pressing in. And then instead, we end up pressing into our hand with something else, like this pencil with the same force. I can't do it, because if I do the same force, I'm actually going to puncture my skin. But the reason why this would puncture my skin, while my finger with the same force does not, is because here the pressure is less because I have more area on the tip of my finger. While here the pressure is more because I have less area on the tip of the pencil. So that's why pressure matters. As I change the area that a force is acting on, I change the pressure. So if I take a look, and notice we're not looking at page 304, but here's the different variables. Here's the formula for pressure, and let's talk about what everything is. So P is, of course, pressure. This is normally shown with a capital P, okay? And the unit for pressure that we're going to use most often is something called a Pascal. You're going to learn Pascal's Law in a second here. So scientists that dealt a lot with pressure, but Pascals are PAs, capital P, lowercase a. That is the unit. Just like the unit for force is going to be newtons, the unit for pressure is going to be pascals. And I'll just write here Pascals. That actually should have a capital. Let's respect Pascal by capitalizing his name. And then we have F, which is, of course, force. You know the unit for this sucker. It's newtons. And then A is going to be area. Okay, so this is the area of a 2D surface, and that's going to be typically in meters squared, or square meters. So, oh, what have I done? So for example, when you talk about houses and how much square footage they have, that's square footage. It's feet squared. You could also measure that in square meters. So it's just how large a surface is. So all we do to figure that out is we measure the distance, right, from the length. So like if I have my graphic tablet here, I measure the length and then I measure the height. I multiply those two things together and I have my area. I have my square meters. So you might be thinking and looking at this formula and realizing that I have newtons divided by meters squared. So then what is a Pascal equal to in terms of a more complicated unit? Well, a Pascal is equal to a Newton per meter squared. Because when you look, I'm taking newtons and I'm dividing it by square meters. Anyways, it's just interesting. So based on the formula, what will happen to the pressure if? Let's go through some different scenarios and see if you can figure it out based on how fractions work, which of course you've learned in math. So what if force increases? What's going to happen to pressure? It's going to go up. What if force decreases? It's going to go down. What if area increases? So the area I'm acting on is going up. Well, then pressure is going to go down. Larger area, It means less pressure because it is the denominator. So as that gets bigger, my pressure is going to get smaller because I'm dividing by a bigger number. What if area decreases? So area goes down. Well, then pressure is going to go up because if I'm dividing by a smaller number, then this is going to end up being larger. So that's how the relationship works. A little bit more about it. Pressure, like I already mentioned, is measured in pascals. Maybe you've heard the term before, kilopascal, kPas. In fact, when we talk about weather and pressure in weather, we use kilopascals. All a kilopascal is 1,000 pascals. When we talk about things like atmospheric pressure, we need to use kilopascals in order for it to be a manageable number. So kilo means 1,000. So that's why a kilometer is 1,000 meters. That's why a kilogram is 1,000 grams. In the same way, a kilopascal is 1,000 pascals. Okay, so that's how it works. We can manipulate, or sorry, no, we're not manipulating. Just again, like I talked about, a pascal is equal to a Newton per meter squared because it's taking the force, right? Newtons is the unit for force and dividing it by area, which has the unit of meters squared. So that's what a pascal is essentially equal to. So pascal's a little bit of a fancy unit where it is simplifying other units in order for it just to be a little bit easier to write. So instead of writing Newton per meter squared, it's a lot easier to write just PA, right, for Pascal. So how does this relate to a bed of nails? I think this is quite interesting. How a bed of nails works is that I have so many nails that when I add together the area is quite high. So as a result, the pressure is brought down. As I take out more and more of these nails, well, then the area that is in contact between the person and the bed of nails is going to be smaller, which is going to result in larger pressure. So a bed of nails has to have a lot of nails. If it had just a few nails, then it would pierce the skin because the pressure would be so high between the nails and the person. So anyways, another way to think about it is that as you end up having less nails, there is more force on each individual nail. So let's take a look at some other kind of scenarios, and we're going to either say if it's true or false. A lot of nice true or false statements here for us to chew on to see if we can figure it out and understand pressure. The pressure will increase if the area stays the same, but the force increases. So let's write out our formula here. Pressure is equal to force divided by area, because I always want to look at that formula in order to figure out what's going on. So the area is staying the same and the force is increasing. What's happening to pressure? It's going to increase. That's a check mark. The pressure will increase if the area stays the same. Okay, area is staying the same and the force decreases. That's wrong. If force goes down, pressure is going to go down. The pressure will decrease if the area increases and the force remains constant. So this is going up and this is remaining constant. Well, the answer to that is yes. Pressure will decrease if I'm dividing by a larger number. Okay, next slide. Let's write the formula again. P is equal to F over A. The pressure will remain the same if the area increases and the force remains the same. No. If the area increases, then that means pressure is going to go down. The pressure will increase if the area decreases and the force remains the same. That is true. And finally, 21 kPa is equal to 210 kPas. That's false. It would have to be 21,000 pascals because kilo, K, means 1,000. So actually, like, this is just two different ways of writing the same thing, right? Instead of writing the 3 zeros, I can write the K to mean thousands, right? Which is 3 zeros. All right, so let's talk about Pascal's law and then start connecting this to hydraulics. So Pascal's law is that when pressure is exerted on one part of a contained fluid, the same pressure is transmitted unchanged to all parts of the fluid, no matter what shape of the container holding the fluid. So if I exert a pressure right here, okay, which causes all of this liquid to have the same pressure, then that pressure will be applied to here as well. And this is the basis of hydraulics. It's how hydraulic systems work in order for us to be able to apply tremendous amounts of pressure with a small amount of force. So I should say a tremendous amount of force by using a small amount of force by using a hydraulic system. So let's take a look at this example. We have a hydraulic system where I have a piston here and a piston here. And on this piston, I have 500 newtons of force and an area of 5 meters squared. And the question is, what is the pressure of the fluid inside of here? Okay, because it's all going to have the same pressure. So I already have my variables written out here. I don't have to do that again. I'm just going to note that I'm looking for pressure. So let's try it out. Pressure is equal to force divided by area is my formula. By the way, you are going to get a formula sheet that contains all your formulas you've learned this unit. You don't have to memorize them. You just have to know how to use them. So I have 500 newtons divided by 5 meters squared. So 500 divided by 5 means I have 100 pascals. So I'll write that again as one other line here. So all of the fluid here has 100 pascals of pressure. Moving on to the next question. This is kind of neat. So if we know the pressure on all the fluid, which is 100 pascals, then what force would be exerted over here on this larger piston? So remind you that it was 500 newtons of force over here. And I had an area of 5 meters squared, which resulted in 100 pascals of pressure. And now the question is, well, what kind of force is exerted over here? So I know that pressure is equal to force divided by area. The information I have is I have pressure is equal to 100 pascals. I have area is equal to 50 meters squared. And I want to find force. I know that this is a little bit complicated for math, and this isn't a typical question, but in order for me to find force, I need to multiply both sides by area. Right now it's on the bottom. I need it to be on the top, so I have force alone so I can solve for it. Whatever you're solving for, you're always getting alone. So because I have area on the bottom here, I'm going to multiply both sides by area in order to get it on the other side. So it cancels out here, and I have that force is equal to pressure times area. Force is equal to pressure times area. So my force is equal to 100 kPas multiplied by 50 meters squared. And holy smokes, I get 5,000 newtons. Wow, that's crazy. So by applying 500 newtons here, I get 10 times the force over here. And this is how things like hydraulic jacks work to lift up cars and stuff, is the fact that by using a hydraulic system, a small force can be turned into a massive force by using Pascal's law. It's really quite neat, very cool. And that can happen in a small amount of space as well, unlike a lever or something. So by exerting 500 newtons of effort force on the large piston, or effort force, the large piston exerted 5,000 newtons of force on the load, which is 10 times, is the mechanical advantage. We use the same way to calculate mechanical advantage as we did for levers. We just do load force divided by effort force. Now, what is interesting is that just like for the lever, I would have to push the small piston down 10 times as far as the large piston. So if I were to push down that small piston over here, 10 centimeters, then this would only go up 1 centimeter. Okay, so just like a lever, that I would have to lift a bunch, right, or push down a bunch in order to lift this just a little bit. So the same amount of work is done on both pistons, same amount of work, same force times distance, right? But it's giving a force advantage so that I can apply more force by going a larger distance. All right, let's talk about pneumatic versus hydraulic systems. So pneumatic systems is a system in which gas transmits a force exerted on the gas in a closed space. So these are two types of fluids, right? Gas and liquids are both fluids, but pneumatic systems use gases, and then hydraulic systems use liquids. Pneumatic systems, when we talk about gases, typically have to do with very fast movements, while hydraulic systems are normally slower and giving like a force advantage. So pneumatic normally has to do with speed and a little bit of springiness, while hydraulic has to do more with a force exerted. And I don't know why there's a period here instead of an S. So hydraulic is a system in which liquid transports a force exerted on the liquid in a closed space. Okay, so let's take a look at a few different examples and talk about whether it is a hydraulic or a pneumatic system, and try to use what I talked about, that normally pneumatics have to do with speed, while hydraulics have to do with force. So an air nail gun, air nail gun. This is, surprise, surprise, pneumatics. Woo. Dump lift. This is going to be hydraulics. Arm used to move the bucket on that excavator dozer thing. I don't know my equipment. This is hydraulics. Excuse me. Oh, wow. Jumanji. Okay, next, dental drill. This is, oh, speed, pneumatics. Jackhammer. Again, super fast, springy, pneumatics. And finally, Lamborghini door, allowing that big old door to swing up the way it does. This is hydraulics. So again, hydraulics is a liquid and it has to do more with force, while pneumatics is air, gas, and it has to do more with speed. All right, well, that's pressure and force and Pascal's law and hydraulics and pneumatics. Hopefully it made sense. Have a good rest of your day.